Okay, Dumela. Last time I discussed the topic of Naya Motlakase, so we are going to do a quick review and then take questions at the end of the topic. Really, what is electricity? Electricity is the flow of electrons, right? There is what you call an atom, and an atom has three subatomic particles. Of the three subatomic particles, two of them, being protons and neutrons, are locked within the nucleus and are unable to flow. We have one subatomic particle which we find outside the nucleus, which is free to flow, which is mobile. So it makes a very good exam question. Of the three subatomic particles, which one is mobile or which one is able to flow? It is an electron. Yeah. So similarly, an electron, electricity is the flow of electrons. Of the three subatomic particles, electricity, the only one which is able to flow. Electricity is the flow of electrons. So that should come to your mind. Why are these electrons flowing? There is what you call the potential difference. And what to begin with, there's a couple of parameters that we are going to discuss, and all these parameters need abbreviations, right? Potential difference, PD. So by potential difference, we are simply talking about the difference in the potential, the electric status between the 2 points, between the positive terminal and the negative terminal. So just an illustration or potential difference. How only put a plus a positive side here, and then you have a negative side here. Then you keep your electron right in the middle. An electron is going to experience two forces, right? It is going to be like charges repel. So an electron is going to be repelled from the negative side. At the same time, it is being attracted to the positive. So that repulsion and attraction to the positive side, that force of repulsion and attraction experienced by these electrons, that is what we call potential difference. The other name is voltage. Potential difference because these 2 points are different electrically, and that's what subject force more electron in your flow from negative to positive. It is measured in volts. This potential difference of voltage is measured in volts, right? Voltage le negative 1 this side, le positive 1, difference in 2. How le negative le positive side, negative 1 le plus 1. How the difference or plus 1 minus negative 1 in plus 1 minus 1 in plus 2. So in voltage here 2. How the electron say the electron di le 4 the proton di le 4 and the negative di le 4 the other side. On a negative 4, on a plus 4. So how plus 4 potential difference. How the difference subtract, right? Where minus difference subtract minus 4 in plus 4 minus in plus 4 in 8 volts. So that's what you call a potential difference. So the force that is going to be experienced by an electron are being pushed on the other side by negative 4 and then being pulled on the other side by positive 4. Force at the 8 volts, right? So that's what we mean by the potential difference. It is the gradient that pushes electrons around the circuit. So potential difference plus then the negative, right? So it is that force that is going to be pushing electrons around the circuit. So for you to have electricity, the first thing that you need to have is potential difference. You can never have electricity without a potential difference. Right? So le go motlakaseng gore go na le motlakase go tlileng pele go tlile potential difference. It is the alpha. It is the alpha of electricity. Yeah. So we use potential difference. The other name is called volt, abbreviated as V. Potential difference abbreviated as PD. It is measured in volts, abbreviation small v. It is measured in an instrument called voltmeter. So now the instrument. While let's go through all these parameters, instruments. So this one is measured using a voltmeter, and the sources of potential difference cable cell battery 12 volts. Hello. 240 volts, right? And then, so of these two terminals, the one that is rich in electrons, it is this one. It is this one that is rich in electrons. So, these electrons are going to be subjected to this potential difference, and then they're going to be forced to flow. Once you close this switch, and then the circuit gets completed, these electrons are going to flow around the circuit. Electrons are being repelled from the negative side and attracted to the positive side, right? They're being repelled from the negative, attracted to the positive. So they're being repelled from this negative side. They're being attracted to the positive side. So they are going to flow around the circuit. So electrons are going to flow around the circuit. The flow are pushing this difference, the potential difference. Don't forget that, please. And then remember, we don't just get a single electron flowing around the electrode. We have flowing around the circuit. We have is a group of electrons. So that group of electrons flowing around the circuit, we call it charge. That group of electrons flowing around the circuit represents charge. It's a group of electrons measured in units called coulombs, abbreviated as C. Measured, right? There's no instrument here. We actually calculate voltage charge. We calculate charge. That is going to get important. The other thing is important to examine. Don't forget, for a charge flows in which direction. But may examine for a charge flow in which direction. Charge flow in which direction. Charge flow from negative to positive. Electrons flow from negative to positive. So charge flow from negative side to positive. So don't forget, it flows from, but in which direction? From negative to positive, right? I'll be happy if you don't forget that one. Then the other thing that you should remember, these electrons, as they flow around, they don't just flow empty-handed, right? They are carrying energy. They are carrying packets of energy. Yeah, and that energy electron, it is what we are going to use in the circuit to do work. Remember, energy is the ability to do work. So these electrons are carrying some energy that we are going to use to do some work in the circuit. Lighting. Remember, if you plug a bulb, is going to light. Plug radio sound energy, both sound, both heating, other things like the fan, that's kinetic energy, right? So they're going to do all this kind of work. And then the amount of work done is measured in joules. Remember that is abbreviated as J. Yeah, energy when abbreviated is E or work done. So my example, how to calculate energy and how to calculate work done. Same thing. Don't forget. Yeah. Electrons, as they flow around the circuit, carrying that energy flow. Every time there's energy flow, there's going to be a wave. Got to begin the wave. I think I spend much time getting what is a wave? A wave is a disturbance, and every time there's energy flow, every time when I and then those were waves, right? Yeah. Every time there's energy conversion from one form to the other, there's always a wave. A wave is like a shadow of energy conversion or a shadow of energy flow. So you have these electrons flowing around the circuit and they're carrying energy. So if energy flow in the circuit, there's going to be a wave produced. So it doesn't come as a surprise for we have a wave produced, and this time around a wave produced by this flowing energy in the circuit carried by electrons. This wave is called current. So we talk current is that parameter I is simply a wave produced by flowing electrons. And I like giving guys this analogy. Mo TV ha o bile koloi o tla bona ha koloi e tabogile ya kwa matwana teng ke a boa reverse, ha koloi ya go pele o tla bona ke matwana teng a boa reverse. That's a wave. So electrons flowing from negative to positive, electrons flowing in this direction from negative to positive creates a wave which moves in reverse direction. They produce a wave that flows in direction opposite direction from positive to negative. So look, the current flows from positive to negative. That's why we call it a positive wave. Current flows from positive. Don't forget that direction, please. It's very important. True or false. For in which direction does current flow? Which of the following is true? Current flows from positive to negative. Electrons flow from negative to positive. And then we use an instrument called ammeter to measure current, and the units are abbreviated as A. Yeah. This one we have an instrument. And then the other thing important that you need to know is that these electrons don't just flow freely around the circuit. They experience resistance. They experience inhibition. So that inhibition to flow of electrons is what we call resistance. It's abbreviated as R, and is measured as in ohms. Last time if you were to an example level le wire e kima le wire e tshesa, the electron di flow mo tlhofo go ntse they flow easily mo tseleng e kima le mo tsela na re itse gore tsela e isang go tatlhegong ke bulegileng. Yeah, it's about mudubudu, right? Tsela e bulegileng tsa ba mudubudu. So tsela e tshesane ke na le high resistance. So le go electron go ntse la wire e tshesane na le high resistance e tsama di electrons di nyenyane. Wire e kima e bulegileng e tsama ena le low resistance. So high resistance thin wire, high resistance thicker wire. But there are other factors that affect resistance. Can already discuss but for now, resistance is that inhibition to flow of resistance. So because by inhibiting flow of electrons, it's like we are trying to bring an end to a flow of electrons. Measure resistance ka mo re ke omega. Ha ba tsana nkere ke batla ba utlwa go go le alpha and omega tshimologo le bokhutlo, right? Ha ona ntse go morena ke alpha and omega. Alpha ke tshimologo, omega ke bokhutlo. So because resistance is trying to bring an end to flow of electrons, it's trying to stop flow of resistance, we measure it in omega, in ohms, the sign of omega. So o ka bona gore ha ne do ma-scientists ba dirile sentle o ka be ba le because for you to have electricity in the first place you need voltage or potential difference. O ka be hala le potential difference re measure ka alpha, right? Ka alpha ela go se re measure ka omega, le sa measure ka voltage. Then next na girialo the other thing that you need to know ke gore mo botshelong it's not only important for you have done work, right? It also matters for that work was done in how much time. It matters. Kore ha ka hira batho ba le 2 ba go apela o bongwe ba go apela dijo in 30 minutes, o bongwe ba tsa a day go ra di apela. Ha o hira ga wana go hira o apeleng dijo hela o hira le go ro di apela mona go nyako. So it matters gore tiro e dirile mona go nyakana kana. That's what we call power. Power is the amount of work done per time. It's a rate, right? Anything that is per time mo exameng is a rate. Ha ba ka go botsa potso ba khona ba tapotse mo exameng ba re which of the following are rates, or which of the following is a rate, or which of the following is not a rate. Go go betsa go teng ke per time. Tse go teng di per time hele ke tsone di rate. Salary is per time. Ha go tamogela tripula per month. month ke nako per month, that's a rate. A salary it's a rate. So I ke tla go duela o nkagele yane mme per hour ke go duela bokana per hour, that's a rate, right? Bo velocity is equals to, or speed equals to distance per time, those are rates. Anything per time is a rate. Let's kind of like what like per time, that's a rate. So let's go about the read back the examine. As you go along, so power is measured in units called watts. Then at this moment, I'll briefly show you what the formula the second read these same formulas. So level like a speed. Say why. There's a relationship between current. There's a relationship between current and voltage. Rare. Every time we increase a voltage, the current there increase. So rare, those things are rare. Current the voltage, they are directly proportional, right? Directly proportional. Proportionality. I will current le resistance. If you increase the resistance, voltage ke force le gore e push the electron. So how gets a force le gore push the electron ka current being current ke di electrons tse di flow around circuit. So if the electrons di push on gona dintse le current ya gona ntse, because current is simply a shadow of flowing electrons. So how gets a resistance kana go khana di electrons ke di flow. How khana di electron le current ya go fokotsega, right? So current and electron, they are inversely proportional. How do they inversely proportional? This is how we write it. Current is inversely proportional to resistance. They are directly proportional. So if you combine two, go physicsing, every time we combine two or more proportionalities, we make an equation. On the left side here, we have an I, right? We have an I on the left side, and then we combine these two proportionalities, we make an equal sign here. V usually V over 1. What V usually V over 1, right? When I go to division line, rale 1 over R. R what is a division line? So rale I equals to V over R. So the little formula I equals to V over R. And we can go ahead and make V the subject of the formula, better V equals to IR, right? Memorize this first formula of electricity, and then now we are going to relate charge. We are going to relate charge to voltage, to current and time. Current again, charge le time le current di rita ka tseleng. If you increase charge flow mo seketeng, le current ya go oketsega, agare current ke moruti wa charge flow. So they are directly proportional. If mo seketeng o relate charge le time, if charge e dikologang mo seketeng, if you are seated somewhere in the circuit, and over the electrons di fetang feta di go ga di feta go feta 1, 102, 103, 104. The electrons as time goes, as time increases, the amount of charge, the amount of electrons passing this particular point is going to keep on increasing. The number of cars passing that particular point is going to keep on increasing. The number can never go down, right? So the charge is directly proportional to time. If you combine these two proportionalities, there's Q this side, and then Q on the right side on the ILT, where Q equals to IT. So to formula Q is equal to Q equals to IT. The formula charge equals to IT. These two formulas are together because can you measure voltage? Yes, you can measure it using voltmeter. Can you measure current? Yes, using an ammeter. There's only one variable, so it's acceptable. So here, can you measure current? No. Can you measure current? Yes. Can you measure time? Yes, using voltmeter. There's only charge that you cannot measure. So if there's one variable, the formula is acceptable, then you come to the next formula. The lower later energy, right? The lower later energy, right? The amount of energy in the circuit done. We are going to relate it to number of electrons, and then again we are going to relate that amount of work done to voltage. So level tiro mo seketeng e dira ke di electrons, right? Charge. If we increase a charge, what is going to happen to the amount of work done mo seketeng? Charge ke yone babereki mo seketeng. If babereki ba nna bantsi, tiro ya go nna ntsi. So our work done is directly proportional to charge. How it like a fanega, rather make charge you if I push ke voltage around the circuit. So how we increase a voltage, what is going to happen to the amount of work done? How we increase a voltage, the amount of charge flowing is going to increase, and as a result, the amount of work done also is going to increase. Combining the two proportionalities, work done on the left side is equals to on the right side QV is equals to QV. So when examining, you may get questions tsa formula ya gore work done equals to QV. So the calculator for work done is equals to QV. Formula you may get questions, but ga se gantsi ka bona dipotso tse dintsi mo go yone mo examing because ga re rate mo examing. You know why re sa rate? Ga re rate because we have too many variables. Work done, can you measure work done? Can you measure charge? No. The only thing that you can measure here is voltage. So the formula because we have two variables. If every time we have two variables, you need what you call simultaneous equations, right, to be able to solve this one. So we now have a task of simplifying this formula. Q equals to Q equals to IT. So I will Q IT to simplify this formula. Work done is equal to QV. Then I will Q IT. So energy equals to ITV. Formula because you can measure voltage, yes, voltmeter, you can measure time, you stopwatch, you can measure a current ammeter. There's only one variable. So this one work done. Let me memorize. Work done equals to ITV. It's like a television station, BTV. Work done is ITV. So memorize this formula. Every time you don't feel a current, the time voltage, amount of work done. You are simply going to multiply the three parameters. Work done is equals to ITV. Simple. Then the last formula, it doesn't only matter how you relate to, right? It matters how you relate to power is the amount of work done over time. So how do you start to terms of electricity? Work done ITV, right? So that power equals to ITV, work done ITV. So power equals to ITV divided by T. T you cancel a T, power equals to IV. Power equals to IV. So every time we give you current and voltage, you should be able to get wattage or power, right? And then two more formulas to go. I equals to V over R. So Denver, power is equals to IV, right? So how I go? V over R, V over R times V. I agree V over R get I. Then you are multiply by V. V times V in V squared over R. So power equals to V squared over R. The last one power equals to IV. The last one is V equals to IR. How V equals to IR. Then I times I squared times R. So power equals to I squared R. So those are the only formulas that we are going to use to calculate the coming questions. And then the second, series second, the parallel second, then we'll be done. Thank you so much for your attention.